Hi and welcome back to Inequalities video 2. In this video we'll look at inequalities in two dimensions, sketching on a set of axes and how we can mark the region that is defined by the pair of inequalities. I'm going to show you this through examples and hope that you can build your understanding through examples. And it will rely a little bit on your past knowledge of linear functions, and I'll be assuming that knowledge. So if that's an issue, go back and look at linear functions and come back and watch this video later. So let's have a look at our first example. Example 1. Let's sketch y is less than or equal to 2x minus 1. First of all, we need to identify some things about 2x minus 1. The y-intercept is minus 1 and the gradient is 2. So the first thing I'm going to do is appropriately label my axes. Now, I can go up in 1s, 2, 3, 4, etc. on my x-axis, and I'm going to go up in 2s on my y-axis. I'm just making this choice to make sure that my graph fills a predominant amount of the page. You don't have to fill in all the numbers as long as you've got enough to make sure that we understand exactly where things go. Now, first of all, there is a point here at -1, and then the gradient is 2. So that means each time I go along 1, I go up 2. That will take me to 1, 1, and I go along 1 and up 2 again. Along 1 and up 2. So on and so forth. If I go backwards 1, I go down 2. And so I get a function that looks a little bit like this function here. Starting down here, it heads up and it carries on in both directions. So that green line represents our function. Now we need to sketch the region. So let's just note here the important things about the region. This says y is less than or equal to 2x minus 1. So to test this, I'm going to pick a point. And wherever I have the opportunity, I'll pick this point here, 0, 0. Because it's really the easiest one to substitute in. So over here, I'm going to start with y is less than or equal to 2x minus 1. And I'm going to put in 0, 0. Is 0 less than 2 times 0 minus 1? So is 0 less than -1? And the answer is that this is false. And that means that this point does not lie in the region, which means our region must be everything on this side of the line. So everything below the green line exists in this region. Now, of course, at this stage, you might wish to test another point. You may test 4, 0, and you'll find that that gives you is 0 less than or equal to 7, and of course it would be true, and you're happy. So that's how we sketch a region. Start by sketching the linear function as if this is an equal sign, and then test the region, just one point, see if it exists in the region or if it doesn't, and shade in the region appropriately. Let's go to example 2. 2y plus x is greater than 4. So for this example, the first thing I need to do is rearrange. So 2y plus x is greater than 4. That means that 2y is greater than 4 minus x. And that means that y is greater than 2 minus a half x. Or you may wish to write it as y is greater than negative a half x plus 2. And of course this means that m, our gradient, is equal to negative a half, and our y-intercept is equal to 2. So again, I'll label my graph, but this time, knowing what my graph is going to look like, I'm going to go up in 1, so that will be 2, 1, 0, -1, -2, and I'll go up in 1s here as well. 1, 2, 3, 4, -1, -2, etc. So first of all, I have a y-intercept of 2, so that's just here, and I have a gradient of negative a half. So each time I go along 1, I go down a half. Long 1, down a half. Long 1, down a half. Long 1, down a half. You see what's happening and what this gradient means. If I go backwards 1, I go up a half. That's what the gradient means. Really, I only need 2 points, but it's always good to have that surety. And of course, my graph now looks like this. And it carries on forever, like such. Now, I need to test a point in the region. And again, I'm going to be a little bit cheeky and choose this point here at 0, 0. It really is just the easiest choice. Of course, if the line goes through 0, 0, then I need to make sure that I have chosen a different point. So I'm going to first of all test just the original function 2y plus x is greater than 4. So is 2, 0 plus 0 greater than 4? So that means is 0 greater than 4? And the answer is that is false. So again, that point we chose is not in the region, so our region is above the purple line. There it is there. Now there is one thing I've neglected here, and that is to recognise that this is actually just saying greater than, but not greater than or equal to. So I'm going to go back to the original function here and have a look at the line I've drawn. Greater than means that it's not equal to, and I need to be a little bit clever about my representation. So I'm actually going to go through now and make this a dotted line. And making it a dotted line actually just indicates that this is, not doing a very good job of the dotted, but you get the point. This is greater than, but not equal to. So if you have a greater than or equal to, you have a full line. If you have greater than, but not equal to, you have a dotted line. And the same with the less thans. Now let's have a look at one last example. Example 3. So I've got two different inequalities this time, but slightly simpler functions. So I have y is less than 2, and I have y is greater than or equal to x minus 3. So let's start by sketching the y is less than 2, and I'll do this one in orange. So y is less than 2. Well, first of all, I need to set my scale. And I'm going to set my scale as going up in 1. So I've got -3, -2, -1, 0, 1, 2. And going up in 1s again here. These are fairly simple and close-knit functions that stay near the origin. Okay, now y is less than 2. Well, the line y equals 2 is actually a horizontal line. So I'm going to draw this horizontal line here. You'll see that if you go back to your work on linear functions, you'll recognise that this is the line y equals 2. Now I have to be a little bit careful because obviously this should be a dotted line. So I'm just going to go through and rub out some points to make sure it's dotted. And this is now going to be the line that represents y is less than 2. But I'm not going to do any regions just yet. So next I'm going to draw the line y is greater than or equal to x minus 3. So I'll do this one in purple. And again, -3 is my y-intercept. So I'd plop a little point here. And it has a gradient of 1. I've got a long one, up 1. Long one, up 1. Long one, up 1. Long one, up 1. A long one, up 1. And I get to here. Now, I haven't chosen my scale all that well. So I might just extend this line. Extend my orange line, and my purple line will also have to be a bit longer than I expected as well. So the orange line here so that you can see my region when we get there. And the purple line will just follow this path. So it will start down here and it will follow along this path. Okay, so there's my two lines. Now you notice that this time I've got 1, 2, 3, 4 regions. Now, I'm going to try and be clever about my setting out here. So first of all, I could go through and just test points. But that will actually be hard because I'll have to test up to 3 points before I identify which of those one regions satisfies both of these functions. So what I'm going to do instead is I'm going to test that 1 point again, 0, 0, for both functions. So first of all, y is less than 2. Is 0 less than 2? This is true. So therefore we know that this works for region 2 or 3. So it is below the orange line. And there's regions 2 or 3. And in pink, y is greater than or equal to x minus 3. Is 0 greater than or equal to 0 minus 3? i.e. is 0 greater than or equal to -3? And again, this is true. So that means that we are above the purple line. This 0, 0 works, so we're somewhere in here. You can see the two regions are 1 and 2, which is a single region that works for both, and that is region 2. So now I can go through my black marker here and I can shade in that region 2 is identified as our region that satisfies both inequalities. And you can see that there. Obviously you might shadow it a little bit better. So there's some inequalities in a plane, and hopefully you can extrapolate from that to do some more complex problems as you go. All the best.